Okay, wonderful. We understood important aspects of the big data. So central theme of the big data, like distributed storage and distributed processing. So as a part of the distributed processing, what is happening is we are sending the code to where the data is there. Now, tell me one thing. Why are we doing the distributed processing? For what reason we are doing the distributed processing? Anyone? For what reason?
Storing purpose. For data
Why?
unable to store in 1 GB at all in system.
Yes, wonderful. Okay, as Muthuminal is saying, because of the sheer amount of the data, it may not be possible for us to store all data in one place. Okay, that is the reason we are distributing the data to different systems. And since we are distributed the data to the different systems, instead of sending the data to the code, we are sending the code to the data. That is the reason we are performing the distributed processing. When I say processing, what is the simple example of a processing? Vinit, what is a simple example of a processing? What am I trying to process here? As we discussed in our previous class, what am I trying to process in this data?
Actually, we are deriving the information from the data.
What information? What information?
Processed information, sir.
Okay, I mean, yeah, the simple example of a processing, if you guys remember, I want to like calculate the sum of the salary, right? That is what we discussed, right? Parveen, Anna, sum of the salary. Okay.
Yes, sir.
So if the whole file is there in one system, calculating the sum of the salary would be easy. Okay, sum of this column. Now, my problem is the data is not automated. The data is distributed across different systems. So the processing need to be done at the system level. Like I had to calculate the sum of the salary part 1, sum of the salary part 2, sum of the salary part 3. Then sum of the salary part 1, sum of the salary part 2, sum of the salary part 3 should be, that is the actual sum, isn't it? Yes or no? Anna, yes or no? Right?
Yes,
So
sir.
this I'm saying, see, this is a simple way of processing. Okay. So instead of processing the salary at the one system, since my data is distributed across the different systems, the sum of the salary is calculated at this level, this part, at this part, at this part, and all of that will be added. Okay, all of that will be added. So, but tell me one thing, somebody has to send the data to different systems. Somebody has to do the processing at the system level. Somebody has to collate the data to give a final result. Who will do that? Shabna. Who will do that? Who will do? I mean, you're getting my point, right? So somebody has to distribute the data. Somebody has to calculate the or do the processing at the system level and then collect the results of all this and present. Because the person who is analyzing the data wants the final result. He doesn't care whether you have shared the data, whether you have distributed the data to the different system. He doesn't care. Who has to do this? Who has to do this?
Sir, the programmer.
Programmer. Okay. So programmer has to do it, but it should be taken care by a programming model. Okay. There should be some model to tackle all these things, isn't it, Vinith? Okay. So otherwise, it will not, some ghost or some alien will not come and do it. Something has to do it, right? That is programming model. Okay. Now, Parveen, we understood the programming model has to take care of this. Okay. But if I ask you what is a programming model in generic way, what is a programming model in generic way, Parveen?
Programming model. Program means it's a set of instructions, sir.
Very good, very good. Okay, well, then what is a programming model? Okay, so programming model, it is a very, I'm talking in a generic fashion. It is nothing related to the big data at the moment. Okay, so it is a generic. Programming model is needed everywhere. Okay, whether you are doing any computation, programming model is needed everywhere. Okay, so it is an abstraction or a machinery or infrastructure that includes the runtime libraries, and the programming model is created by a programming languages that can be high level and low level language. Okay. When I say abstraction over a machinery, because we humans cannot talk to the machines in their language, right?
Yes.
Shabna, 001.
I don't know, sir. I don't
Yeah,
understand you.
you didn't understand. Good. Okay.
It's machine
So
language.
that is a machine language. So basically, it's a binary language. So since we cannot talk the binary language, we need to write a programming model with a high level language like Java, C, C++ that has a runtime libraries that will talk to the machine. That is a programming model. Okay. Now let us come back to the programming model requirement for the big data. So we understand the big data is not at one place. Vinith, is big data at one place?
Big data is not at one place, sir.
It is
Actually,
distributed across different
yes, sir.
systems.
Yes, sir.
It is distributed across the different systems in a cluster, commodity clusters. Okay.
Yes, sir.
So now, if I ask you a question, Vinith, what kind of a programming model is needed for processing of the big data? What kind of a programming model is required? You understood what is programming model? Right? Programming model is
Yes,
it's kind of a,
yes, sir. Yes, sir. Yes, sir.
so now what kind of a programming model we need for the big data? That is the question.
So that the whole environment of the processing
Mhm.
that can support the whole environment of processing, sir, at runtime.
Okay. Okay.
That
Okay.
kind of model.
Okay. So the first and foremost requirement is because big data is distributed across the different systems, the programming model should have a programmability over the distributed data. Okay. That programming model should be able to have a programmability over the distributed file system. What does it mean? Okay. When I say programmability, I am talking the programming model should support the big data operations. Okay. And it should handle the fault tolerance. And it should be allowed to add more racks. Okay. So these are the requirements of a programming model to support the big data processing. Okay. It's clear to everybody, right? Or let me kind of drill down in each of these things. Okay. When I say support the big data operations, okay, and also the last one is optimize for the specific data types. Okay. When I say big data operations, what are the big data operations you can think of? Anna, what are the big data operations?
The adding data, inserting.
Okay. Okay. I'm
Up-
talking about the big data operations. You are telling me the SQL operations. Tell me about the big data. What happens in big data? Anyone? Anyone? Any thoughts?
Data
from anyone?
integration,
So it should support all
data
the
storage, data
characteristics.
processing, something like that.
Okay. Okay. Good. Thanks for trying, guys. Okay. So see, since the data is big, first and foremost thing is it should be split into smaller chunks, right? So that programming model should know how to split the big data, large amount of data into smaller chunks, right? That is one of the big data operations. Okay. The second operation is it should also distribute. It should also basically once you divide the data, split the data into the smaller chunks. That should also be sent to various systems to store. And we're not storing the data for heck of the data, for heck of storing. We are storing the data to access also, to access the data, which is there in different systems. Okay. And also, since our data is there in different systems, the programming model also should support distributing the code or computations to the node. Okay. What is this node? What is this node? Any idea what is this node?
System or computers. So
Absolutely. Okay. So when I say we have a cluster, right? In cluster, let us say this system 1 is connected to system 2. System 2 is connected to the system 3, right? So this system is called as a node. Okay. So when I say node, visualize that as a system in a cluster. Okay. So programming model should support the big data operations also. See, we are dealing with the large amount of data. understood, right? The large amount of data that cannot be stored and processed by the traditional RDBMS system, that is the big data. We understood how the data is distributed across the different systems in big data, and also we understood how the distributed processing happens in big data. Now, in order to support that, programming model should split the volumes of the data. It should allow us to access the data first, and also it should allow us to take the computations to the node. Okay, understood now? Shabna, you are with me? You're able to get it?
Yes, sir.
Okay. Then fault tolerance. It should also handle the fault tolerance. What is this fault tolerance? What is this fault tolerance? Any idea? What is fault tolerance in generic way? Anyone?
But if
Sir,
any
Yeah, go ahead. One of you, please go ahead.
if any node fails or if any something fails, the remaining operations should continue as usual.
Absolutely. Wonderful. Muthuminal, you got that? What Parveen is trying to say? Muthuminal?
Yes,
Okay.
sir.
So, in general, Shabna, fault tolerance is the property that enables a system continue operating properly in the event of the failure. See, please pay attention. Continue operating properly even though there is a failure. Okay, that is what is fault tolerance is. It's a property to continue to operate even though if there is any failure is there in the system. Now, Vinith, remember you asked me a question,
yes, sir. I did.
right? Now, are you able to,
Yeah, I got my answer, sir.
right? Okay.
Yeah.
So, in case on the day, if you guys remember, Vinith asked a question. We have system 1, system 2, system 3. Now, the data is distributed data part 1, part 2, part 3. He asked a question. In case if one system goes down, my data is gone. Okay. So, programming model also should take care of that because systems are bound to fail. How they are doing it, we'll discuss it later. But here in big data, we should allow us to replicate the data part. Replicate means make a copy. Okay, and recover the files as and when needed. Okay, got it? Anna, Parveen, Shabna, you guys got it? So
Yes, sir.
basically, what we are
Yes,
talking here, Shabna, is big data. We know it's a large amount of data. If somebody has to process the big data, we need to have a programming model. So what should be the characteristics of the programming model to process the big data? That is what we are discussing here, Shabna. Okay. First thing is it should support the big data operations. What are the big data operations? Big data operations are splitting the volumes of the data, means breaking the big data into smaller chunks and accessing the data fast and taking the computations to the node. Node is nothing but a system. Okay, that is the first thing. This is the first thing. Within that we have 3. Okay, and then it should also support the fault tolerance. Fault tolerance is nothing but a property that allows the system to continue operating properly even though there is an event of failure. In case of big data, even though one system fails, we should not lose our data. In order to accomplish that, it should allow us to replicate the data. Replicate means making a copy. Let us say part 3, it should be one more part 3. Got it? Shabna? Anna?
yes, sir.
Okay. So that is okay. And the next thing is adding more racks. Okay. See, any idea what is adding more racks, Vinith? What is adding more racks?
Adding some more system to the already present system.
Absolutely. Bingo. You'll get a chocolate for this. Okay. See, racks are here. The reason we are seeing racks because, okay. So the reason we are seeing racks because, okay. So now in the server, okay, this is a rack. Okay, are you able to? This is a rack. 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 Okay. So adding more rack. This is nothing but a one CPU, which is horizontally stacked, right? So when I say adding more racks, it is nothing but adding more CPUs, which is nothing but adding more capacity. Make sense? Are you able to get it, Muthuminal? Adding racks means adding more capacity. Okay, because can you see it,
Sir.
right? This is like a rack. In rack, it is like rack. Okay, CPU 1, 2, 3, like this. Okay, these are the racks. Adding more racks means adding more capacity. Let us say we have a capacity of 250 GB RAM. Are you guys with me? Is it boring? Are you guys with me?
Yes, sir.
Okay. So now assuming that initial capacity is 250 GB RAM and 500 TB hard disk. Okay. Because we have a increase in the business, we are getting more amount of data. In that case, the capacity required will increase from 250 GB RAM to 500 GB and 500 TB to 1000 TB. Now, our programming model, if it is working at this level, in order to increase the capacity, we have to add more racks, right? If the programming model is working for the initial capacity, it should also work for the required capacity also. Okay, you guys got it? So programming model should also work for the storage. If we extend our capacity, whatever the programming model which is to work at the initial capacity, it should work for the required capacity also. Okay, so you guys are getting right. See, it's for example, let us say you Vinith will write one Python program. Okay, so that Python program works in one system. Okay, now because of the data is there in two systems. The Python program should not complain, I will work only with the one system. Okay, as and when the systems are getting added, the data is getting distributed, storage in a distributed manner, the Python program should also be able to work if you go on expanding the system. That is what it means. Correct, Shabna?
Yes, sir.
Anna?
Yes, sir.
Okay. So this is the, okay, within this there is something called vertical scaling and horizontal scaling. Okay. So I mean, in terms of how do we add the capacity? To add the capacity, it can be done in two ways. Okay. So now assuming that like Parveen has one laptop. So Parveen, what is your capacity of your laptop? If you are okay to
8
reveal.
GB. 8 GB, sir.
8 GB RAM.
Yeah.
And what is the hard disk?
16 GB.
No. Hard disk should be more, na? I think maybe some 500 GB.
Oh, okay.
Okay, fine.
Okay.
Just check that. Okay. So as of now, Parveen's system is 8 GB RAM and 500 GB hard disk. Now, because she is into a big data class, she wants more capacity. That adding more capacity can be done in two ways. One is the same laptop, instead of 8 GB RAM, have 16 GB RAM, add one more 8 GB RAM, and also have 500 GB extra. Okay, in the same system. That is called as vertical scaling. Means we're adding in the same thing. We're updating the capacity in the same system. Okay. On the other hand, instead of the way we can do it is, like let us say one system Parveen already has, instead of updating the RAM and this one, we can buy two systems and connect them over a network. Okay. This is called as horizontal scaling. Okay. Here if you see, we added the capacity to the same server. Here in this case, we are adding the systems to increase the capacity. Like initially, there were 4 systems. Now we added 4 more systems to increase the capacity. This is called as horizontal scaling. Okay, you guys got it? Horizontal scaling and also vertical scaling.
Yes, sir.
Okay. Now see, these things are in isolation. All these concepts are in isolation. No, don't worry. If you don't fully understand them, when you watch the video, it will be a bit more clearer. But what am I talking here, Shabna? What am I talking here? What is the topic I'm talking here, Shabna?
About programming model.
Excellent.
Adding more racks. Okay.
Programming model for what?
Big data.
Yes. We are trying to understand what are the characteristics of the programming model that should support the big data. That is what we are trying to understand. Okay. And Parveen, what are the characteristics of a programming model that should support the big data? What are the characteristics?
Characteristics means, yeah, it should.
Requirements.
Yeah, it should split volume of data.
It should support the big data operations.
Operations. All the 6
Yeah.
characteristics we have seen, right? So that is what.
Not characteristics. Okay, basically, I'm talking about the requirements of a programming model. I'm talking about the
Okay.
requirements of programming model.
Okay. Okay.
This one. Okay. These are the requirements of a program. So it should support the big data operations. It should handle the fault tolerance.
Fault
It should
tolerance,
allow us to add more racks. It should be optimized for specific data types.
data
Okay.
types.
So any programming model which supports all these things, then only it should be able to support the big data. Right? Okay. So first thing we understood, right? When I say big data operations include splitting the large amount of data into smaller chunks, and it should allow us to access the data fast, and it should also distribute the computations to the node. Okay, those are the big data operations. Okay, then fault tolerance is nothing but even though if there is a system failure, the data should not be lost. Okay, that can be achieved by replicating the data partition. Replicating is nothing but making a copy of it. Okay, then adding more racks means the programming model should also work even though if the capacity is increased because of the increase in the size of the data. Okay, within that adding more racks, we have vertical scaling and we have horizontal scaling. Vertical scaling is nothing but adding the capacity within the system. Okay, horizontal scaling is nothing but adding the capacity by adding the systems. Okay, you can see horizontal. Okay, vertical because we are adding
we are upgrading the same system.
We are upgrading the same system. Absolutely. Okay. So the
I have
last
a
thing is,
question.
yeah, please go ahead.
Which one is less expensive, or company choose which one? Or
Yeah, you tell me.
vertical scaling or
You tell me which one is more expensive. Just take a guess, Shabna. Take a guess.
horizontal
Yes, you are absolutely right. Because
Hor-
the cost of the servers is really more. Okay. As compared to adding a system. Okay. Let us say a company has a server. If they want to buy one more server, they have to shell out minimum 50K. I mean, in terms of dollars. But on the other hand, if I want to add a system, it will come in $1,000, right?
Okay, sir.
Horizontal scaling will be much more easier and much more less expensive. They are less expensive as compared to the vertical scaling. Okay.
Okay.
And does the big data allow us to do the horizontal scaling? Yes, it does. Because if you remember, this is in a way, it is a commodity cluster. This is a PC. This is a laptop, right? So which are connected over a network. It is less expensive and also it is easy to expand also. Okay. Okay. The last point of a requirement of a programming model is it should be optimized for the specific data. Because in big data, what happens is you will get to see multiple formats. So instead of one programming model taking care of all the different types of the data, it should be optimized for a particular specific of the data. For example, a programming model for the table would be different from programming model for the document. I mean, optimization. Okay. So for a graph, it should be different programming model for processing the graphical data. Okay. And for the stream data, there should be different programming model. Because of this, there are different platforms for graphical processing, for different platforms for stream processing. There are different platforms for batch processing as well. Batch processing is nothing but the processing of the large amount of data which is already there, which is already historical. Okay. So, right, you guys got it?
Yes, sir.
Basically, we discussed about what should be the requirement of programming model that should support the big data. So with that, I will wrap up the class for today. Okay.